Hey guys, welcome back. This is a very interesting video in which I'm going to actually demo a lab where I'm going to take a physical topology and show you how to map it over to a logical topology, a layer 3 topology. This is something that a lot of people struggle with getting in terms with, especially when they take a look at the two different topologies and how different they are, and you need to map them over. I'll give you simple steps that I want you guys to follow to be able to accomplish that, and that will work with any type of topology that you have. All right, so my objective in this particular video, one of my favorite videos, favorite topics, and a very important topic as well, mapping the physical topology to a logical topology. I'll show you the physical wiring of a particular topology and how do you convert it into a layer 3 topology. This is something that you do in every network that you go out there. The configuration steps to do it, and then the actual configuration to accomplish that, or actually show you the demo for me doing that. My objective is this, and this is where it becomes a little daunting. If you take a look at the two topologies that you have over here, this is your physical topology. In this physical topology, I have two switches, switch 1 and switch 2, which are connected or trunked to each other. You also have 4 PCs, which will be in 4 different VLANs, and I'm also depicted that for you guys over here by showing you that PC1 is going to be in VLAN 10, PC2 over here is going to be in VLAN 20. I'll put the different colors over here, at least try to match it as close as possible. And then you have, let's say, what do you call it, PC3 over here, which is in the blue VLAN over here, which is this guy. And then you have PC4, which is in VLAN red, and I'll use purple because I've already used the other version of red on this over here. But now my objective is not that they're in 4 different VLANs. I want them to connect up to each other. And the way I want them to connect up to each other is in this logical layer 3 topology. So if you take a look at the two topologies side by side, you'll say, hey, listen, they're completely different. How do I map it over? The basic thing, the trick around over here is just to focus on a single VLAN and take a look at what are the different parts or different devices that are part of that VLAN. And you map those devices to that particular VLAN, and the entire thing will be done. The tricks over here that I've basically shown, I want you to see, is how do you create a router on a stick, a router with 2 interfaces to connect the different VLANs. So I'm also doing inter-VLAN routing over here. And I'm also showing you the third aspect of it, which is the switch with what? The SVIs to connect the different VLANs to each other. So this is a logical layer 3 topology that I want to accomplish, but the physical layout, the way it's given to me, is like this. It could be any layout. The methodology that I'm going to show you to map over this to this will remain the same. It's a step-by-step procedure that you need to go through. All right, so let's go ahead and take a look at how to do that. First thing, let's just go over the what do you call it, the slides, take a look at the things that I just mentioned to you, just go over it, recap that. One of the most underrated aspects of networking is the ability to create a logical layer 3 topology from a physical topology. And that's the one that I want you to be experts at. The previous slide had both the diagrams side by side, which is this guy over here, physical on the left side and the logical on the right hand side. Once I get the logical topology, I really don't care about the physical. But to get to the logical topology, the layer 3 topology, I need the physical because I need to know where the ports are connected to. All right? Although the traffic flow will eventually have to go through the physical switchboard, but the layer 3 will control it. So for example, let's say PC1 over here wants to talk to PC2. There are 2 ports on the switch, but if you take a look at the logical topology, PC1 is in VLAN 10 in this subnet, and PC2 is in 192.168.2.0. So PC1 and PC2 cannot directly talk to each other like that. So what has to happen, it will flow along the logical path, which is taking the doing an ARP for the default gateway going to router 1's E00 interface, so the traffic will flow like this into the router. Router will route it to E01, which is like this, come back, and this time around it's going to go into the green VLAN and hit the PC like that. So it's a logical topology that will determine the flow. So the flow will not go from E00 or E01 of the device to E01. It will go from E00 to the router port, go get routed through the router, come back into the switch, and then into PC2. Why? Because the logical is the one that controls it, what VLAN you're in and what is the device that you're connecting to. If it's in a different VLAN, it needs to go through the router. The switch is just providing the physical path for it. In this topology, we'll be routing using all three methods that we talked about in the previous video. Remember the three methodologies? Just to recap for you guys, what are the three methodologies that I use for inter-VLAN routing? I have 4 VLANs, by the way, over here. I'll use the methodology that will use the two interfaces on a router, a multiple interfaces mechanism. We'll also use the one interface on a router, which was a router on a stick. This is using sub interfaces, so I'll need to create the corresponding port as a trunk. You'll see how to do that. Number 3 is the layer 3 switch. All right, just to show you the topology again, where each one of those aspects is taken care of. So over here, this router 1, will have 2 interfaces connected to the switch environment to connect VLAN 10 to 20. Router 2 is using the same interface, sub interfaces, to connect PC2 to PC3, and switch 2, which is a layer 3 switch, will be connecting 30 to 40. The reason that you're not seeing switch 1 in this logical topology, because in my example over here, switch 2 is a layer 3 switch, which has routing capabilities. Switch 1 is not doing any routing, it's just a layer 2 switch. So anytime you have a layer 3 switch, it will appear on your layer 3 topology. A layer 2 topology or layer 2 switch will not, because it's just providing the physical connectivity over here. All right, so that's this over here. The thing that you need to understand, this is where the methodology that I'm going to teach you over here will help you do the mapping between the physical to the logical. All right, what are the 4 steps? These are my 4 steps that I want you guys to follow every time to set it up. The first step over here is to set up a trunk. Trunk between what? Between the 2 switches. So that over here is here. So my first step, before I do anything else, is set this as a trunk. So the 2 switches now will act as a single switch fabric. So whatever traffic gets forwarded, the frame that gets forwarded between switch 1 and switch 2 will have the VLAN tag maintained, so I can put the ports in the appropriate VLANs on either switch. All right, that's step 1. Step 2, configure the switches, the 2 switches with the appropriate VLANs. And in my case, how many VLANs do I have? If you take a look at the topology over here, you have 4 VLANs. What are the 4 VLANs that I need to create? 10, 20, 30, 40. Those are the VLANs over here. I'll create them on switch 1 and switch 2. I don't want to worry about the VTP portion over here, because my focus right now is strictly on the mapping of the physical to the logical. So that's my second step over here. The second step, again, very simple. Configuring what? The VLANs on both the switches. So trunking and switching. Now this is the long step. Assigning ports to the appropriate VLANs. This is the one that I need to focus on one VLAN at a time. There's a whole bunch of this that needs to be done. So if you take a look at it over here on the diagram, what I'm going to do is, first thing, I'm going to go to VLAN 10 and take a look at the 2 ports that are part of VLAN 10. I have PC1, which is this port, and R1E00 in VLAN 10. So I'm going to assign these 2 ports, E01 on switch 1 and E10 on switch 1 in VLAN 10. Once I've done that, the physical to logical mapping for VLAN 10 is done. All right, then I'm going to go for VLAN 20. VLAN 20 has 3 ports, PC2, so PC2, which is this guy over here, this port, R1 R1's E01, which is this port over here, and this guy, R2's E00.1. Oh, there's a sub interface. Do you guys remember what I told you about the sub interface? Anytime you see a sub interface on the logical layer 3 topology, the corresponding port for the physical, which is E00 for R2, E00 for R2, this guy has to be a trunk. So anytime you see a sub interface on the logical topology, the corresponding switch port needs to be a trunk. So I don't need to worry about assigning it to a particular VLAN. I'll just trunk it. And if you want to be more specific, you'll see that this sub interface, the physical interface, will be carrying traffic for VLANs 20 and 30. I can do a switch port trunk allowed VLAN for 20 and 30 over there. I'm going to go through each one of them one step at a time. So then the next VLAN that we have is VLAN 30. This one is taken care of because this port, when I trunk it, I'm trunking the physical port, so it takes care of the two sub interfaces. Once that's done, I'll focus on switch 3. PC3. PC3 is this guy over here. This should be in VLAN 30. Now the other port in VLAN 30, these two are taken care of now, is an SVI on switch 2. So I'll create an SVI on switch 2 for VLAN 30, should be interface VLAN 30 for this particular network. Don't forget, in order to make this into a layer 3 switch, the command that I need to turn on is IP routing. So that would take care of VLAN 30 as well. And then I focus my attention to VLAN 40, which has PC4, which is this guy. This port should be in VLAN 40. And I need to create an SVI for VLAN 40 over here on the 4 network. So I'll do that for switch 2 as well. So switch 2 will have two SVIs for the inter-VLAN routing between 30 and 40. So essentially, I've done two things over here. I've basically taken care of the inter-VLAN routing using the three aspects, 1, 2, and 3. And I'll show you how to do the physical to logical mapping. Again, to recap, what are the 4 steps? Oh, I've done 3 steps right now. The 4th step I haven't talked about. The 4th step is easy. Configure the layer 3 topology. Set the IP addresses and run a routing protocol so I can go from end to end. All right, that's the 4th step. So now let's recap the 4 steps. And this is what I want you guys to know and commit it to memory, that I need to have 4 steps to do a physical to logical mapping. And what are the 4 steps over here to do that? Step 1, trunk between the switches. 2, create VLANs. 3, assign ports to VLANs. And this is the one that you need to focus on one VLAN at a time. And number 4, the last one, is the layer 3 setup, which is IP addresses and routing. All right, let's go get to it and get this configured. So let's start with the first step over here, and I've shown you this configuration over here. Create the layer 3 topology using the connections with the physical topology, assign IP addresses to all devices, run EIGRP and AS100 as the routing protocol, make sure all the PCs can ping each other. So step number 1, trunk, and that's right over here. Configure the trunking between the switches. Trunking is going to be based on the physical topology again, which shows me that the trunk is actually, I need to figure out what interface it is. By looking at it, I might have it as gig 00. Should be good. Let me just check. It is gig 00. I'll just check for you as well. So this diagram is right. This one I need to fix. It is gig 00, which is doing the trunk. And actually it's not E, it is G for me. So I'll just put it over here for you guys. Or to match the topology, I'll just keep it as E. But in my case, it's a gig port. So let's do that between switch 1 and switch 2. So switch 1 over here. Interface gig 0/0. Switch port trunk encapsulation .1Q. Switch port mode trunk. And I'll do the same thing on the other switch. Gig 0/0, switch port trunk encapsulation, .1Q, switch port mode trunk. All right, at this time, I can check my interface trunk and see if it is working properly. Gig 00 is my trunk. If I go to this guy, show interface trunk, I should see gig 00 as my trunk. The only VLAN is crossing over is 1 because that's the only one that I created. That brings me to step number 2. Create the VLANs on both switches. It's the same, VLAN 10, 20, 30, 40. I don't want to use VTP over here. Focus on the physical to logical mapping. So I'll just do that. VLAN 10, 20, 30, and 40. And I'll do the same thing over here. VLAN 10, 20, 30, and 40. That's what VTP would have done for me. I wouldn't have to create the VLANs. So now if I take a look at show VLAN over here, I have the 4 VLANs created. And if I go to switch 2, I should also have the 4 VLANs created. So that's your verification of step number 2. First 2 steps, very simple. Now this is the long step. This is the step that I will assign different ports to different VLANs, one VLAN at a time. Very, very important. This is the key to it. This is where a lot of people lose it because they try to do too many things at the same time. All right. So what are the 2 different ports in VLAN 10? So for this, I'll go to this topology over here. I see 2 ports part of VLAN 10. What are the 2 ports? PC's port and R1's E00 port. So this port, E01 of PC1, which is connected to PC1 of switch 1, and R1's E00, R1's E00 is this port, 1/0 on switch 1. So E01 and 10 on switch 1 should be part of VLAN 10. Let's do that on switch 1. Right over here, switch 1. And I can use the interface range command. Gig 0/1, I believe, let me make sure, 01 and 10. 01 and gig 1/0, switch port mode access, switch port access VLAN 10. You can also verify that by doing show VLAN. Now these 2 ports are part of my VLAN 10, and that does my physical to logical mapping for VLAN 10. These 2 ports are taken care of. I don't need to worry about VLAN 10 anymore. This is done. Now I can focus on my second VLAN, which is VLAN 20. VLAN 20 has 3 ports, PC2, which is E03, R1 E01, R1 E01 is 11, so 03, 11, and the third port is a router with a sub interface E00, E00 sub interface. So on switch 2, this port needs to be a trunk. All right, that's all I got to do is trunk it. The rest of the configuration will be done on the router side to identify the sub interfaces based on the VLANs. I'll have one sub interface for VLAN 20 and another sub interface for VLAN 30 on router 2 using a single interface. So let's do this part first. I have 2 devices on switch 1 that are part of it. Again, look at the device, PC2. PC2 is connected to switch 1 port 3. And the other device on this VLAN, VLAN 20, is R1 E01, R1 E01, which corresponds to E11. These 2 ports should be in VLAN 20. And the third one is a trunk, which is this guy over here. So one step at a time again. Let's do switch 1 configuration, 3 and 1, 1. So switch 1 again, interface gig, or I can do a range, gig 0/3 and gig 1/1. Switch port mode access, switch port access VLAN 20. So this is done over here for switch 1. Now the other port that's missing in that particular VLAN is the trunk port. Trunk port, why? Because the third port, again, as I explained to you, is R2E00 sub interface. So R2E00 is connected to switch 2 port 1/0. That's the one that I'm going to trunk. So I go to switch 2 now, interface gig 1/0, switch port trunk encapsulation .1Q, switch port mode trunk. Now The other thing that I could do is, if you look at this E00 interface, its job is to connect VLAN 20 and 30. So what traffic goes in over here, which will be for the two sub interfaces, are going to belong to VLAN 20 and 30. On the switch, I can tell it the only traffic that I want to send over this trunk, which by default would have carried all the traffic, which includes some broadcast from the other VLANs, I only want to do it for VLANs 20 and 30. So I can do that over here. Switch port trunk allowed VLANs 20 and 30. So that controls the amount of traffic that gets sent to this particular router. So that actually finishes my interfaces all the way till here. It was done. This whole thing is done. Not only that, because this is the same physical interface, I've also trunked it. So this interface is also done. Now, the other interface that I now have is PC3, which is going to be in VLAN 30. PC3 is connected to E01 of switch 2. So switch 2 E01 should be in VLAN 30. The other interface, this one is already done. This I'm going to do. And the other interface is switch 2, and it's an SVI. SVI means the interface VLAN for VLAN 30. All right. So that's the other thing that I need to take care of over here. So let's do that. First thing, E01 of switch 2 should be in VLAN 30. Let's do that first. Switch to E, which is gig 01 for me. Switch port mode access, switch port access VLAN 30. So that takes care of that. And then on switch 2, I need to turn on IP routing. And I'm going to create an interface for VLAN 30. Let's assign it an IP address 192.168. Actually, I don't know the IP address, so I'll just create the interface VLAN for right now. The IP address I have not assigned, and we will do that as we go through it. So, but at the same time, now this part is done, this part is done, this part is done. That completes VLAN 10, 20, and 30. The last VLAN has two interfaces. PC4, which is this guy over here, E03 of switch 2, should be in VLAN 40, and the other interface in VLAN 40 is the SVI, this guy over here. All right, so that would be an SVI interface VLAN 40, so it's ready for the IP addresses. All right, so PC4 is connected to switch 2 port 3, so that needs to be in VLAN 40 gig 0/3 switch port mode access, switch port access VLAN 40. That is taken care of. Switch 2 also needs to have a VLAN 40 created. And that, you guys, completes my mapping. Now at this point, I can just forget this part. I've done my job on this part. Now I need to focus on this, assign the IP addresses, and see if I can have reachability. The PCs I've done. What I've done with the PCs is I've assigned all the PCs .51 on their respective networks. So this one is 1.51, this is 2.51, this is 3.51, and this is 4.51. Normal way of assigning IP addresses, going to the NIC, set the IP address, and I've also set the default gateway. For PC1, it's this guy. For PC2, I need to check. I'll tell you what it is. PC3, I'm using this guy. PC4, I'm using this guy as the default gateway. All right. Probably for this one it's this, but we'll check. So with that in mind, let's get started configuring the IP addresses, and on the routers I'll also do the routing. Now if you take a look at my configuration, I had done this for you guys already. Now this is VLAN 10, the two ports in the same VLAN, VLAN 20. I've done the two ports, and for the third router, which was the router on a stick, this puts PC2 R1E01 in VLAN 20. It also creates a trunk for the sub interface on router 2. That's this trunk. For VLAN 30, it was just one interface. The other thing I had to do was the interface VLAN, the SVI, which will be created as part of the layer 3. In my case, I at least created that VLAN. I didn't assign the IP address. The third interface is the sub interface, which we already did. And for VLAN 40, just the physical interface in there for the PC, and the other one is the SVI, which we'll do as we do the layer 3 configuration of the switch. So that took care of my third step completely, assigning the ports to the appropriate VLANs. One VLAN at a time, take a look at the ports, look at what ports on the switch they're connected to, assign those switch ports to the appropriate VLAN. If it's a sub interface on the device, the corresponding switch port is a trunk. That's all you got to remember. All right. With that in mind, the fourth step, configure the layer 3 topology, the IP address of your PC. Let me show you that. PC is, I think this guy. So what I've done on this guy, if you take a look at it, it is 1.51 and the default gateway is 1.1. So the PC is configured at this point. Now what I need to do is configure the router. Which router am I configuring? The router that I'm configuring over here is, again, I'm only going to look at the layer 3 topology now, E00 and E01 router 1. So E00 of router 1 is going to be 192.168.1.1 and R1 E01 is going to be 2.1. And I'm going to run EIGRP based on my lab requirement as my routing protocol. Remember this? Run EIGRP in AS100. So that's what I'm going to do on R1. How do I do it? Let's go to router 1. Interface E0/0, IP address 192.168.1.1. No shut. Interface E0/1, IP address 192.168.2.1 on the other network. Run EIGRP as my protocol in AS100. Network, the one network, enable that. Two network, enable that. Now at this point, router 1 should be able to ping the PC, which is 1.51. So at least that communication should work, and it is working. Or for that matter, if I go to my PC over here, I should be able to ping 192.168.1.1, which is my default gateway. So this time round, at this point, I am communicating from this guy to this guy. I have also configured routing on this. Router 1 is done. Let's take a look at VLAN 20 now. Router 1 part is done. PC2 is done. I'll show you the PC. It should be 2.51 as I explained to you. But then router 2, the sub interfaces. This is the interesting part that I want you guys to see. This is something that you have not done. So PC2 first. Let's take a look at the PC2. And PC2 should be, I think, this guy, no. I'll bring them up so I know which one is what. This guy is not the one. This guy is not the one. And it has to be the one that comes the last. 2.51, this is the PC. This is PC1, PC2. So on the left corner, I have PC1. The right corner, I have PC2. The bottom left is PC3 and bottom right is PC4 in this screen over here. So I have 2.51. The PC is configured. So that part is taken care of. Router 1, I've already configured as part of my config over here. This guy, 2.1, that is done. I've also enabled EIGRP. Now, the fun part, router 2. How do I do it? I have two sub interfaces. In order to create sub interfaces on the router, first thing, go to the physical interface, which is E00, and bring it up. So I have the interface, the physical interface up. Now once I'm done with that, now I need to configure my sub interface. Based on the diagram, the first sub interface is .1. E00.1. E00.1 belongs to VLAN 10. So when this switch sends me the frame over here, just to show you where it's at, this guy over here, when it sends me a frame, I need to be able to take a look at the frame and specify whether this frame coming in should be for E00.1 or E00.2. And I'm going to do it based on VLAN tags. So 00.1 is associated with VLAN 20. How do I do that? How do I do that config part? Let's take a look. This guy goes over here. So E00.1, I created that encapsulation. The switch is running .1Q and it is VLAN 20. Set the IP address, let's say 2.2, and no shut. Okay. Similarly, E0/0.2, the second sub interface. Now that belongs to VLAN 30. So encapsulation .1Q VLAN 30. So any traffic coming in with a VLAN tag of what? 20 associated with E00.1. So when the switch, because it's a trunk, that's why I created the trunk, sends the traffic into R1 E00 and it contains a tag 20 coming in, it knows tag 20 is associated with E00.1. If the traffic comes in with a VLAN tag of 30, it knows this guy is associated with .2. All right, so that's what's happening over here, and that's what I've accomplished over here. Now from the perspective, once I'm done with the sub interfaces, from my perspective, if I look at my interface brief, I haven't assigned it an IP address. I did do everything else. E02, yeah. IP address is 192.168.3.2. Who's 3.2? This router 2, E00.2, is on 192.168.3.2, this interface. So if I go and check my interfaces right now, you will see in the show IP interface brief, I have two sub interfaces, E00.1 and .2 with those appropriate IP addresses. Now, at this point, I should be able to ping because I have the PC configured already. So I should be able to ping 192.168.2.51, or I should be able to ping R1. Let's check that. On router 2, ping 192.168.2.1, which is router 1. And I should be able to ping 192.168.2.51, which is the PC. All right. If I go to the PC, over here it's 2.51. My default gateway is 2.2. I should be able to ping 2.2. And on that VLAN 20, I should also be able to ping 2.1. So that is also taken care of. Now the last thing on the router is running the routing protocol. In my case, as we had agreed upon, EIGRP 100. I'm already running that on router 1. So as soon as I put my network statement for 2, it should establish an EIGRP neighbor relationship with R1. And the other network that I need to enable is the 3 network. That is the VLAN 30 network. So that is done. If you take a look at your routing table, show IP route EIGRP, I've learned the 1 network via the sub interface. It shows you that in the routing table as well. All right, if now it's just another interface, the way it knows the traffic is for E00.1 is when the switch sends the traffic based on the VLAN tag. I'm saying it over and over again, so just in case you didn't get it the first time around, I want to make sure you get it. All right, so that takes care of this aspect over here as well. This is all working right now. So right now PC1 should be able to talk to PC2. Not only to PC2, it should also be able to talk to 192.168.2.2, which is router 2. Let's check. Let's do that test. Get my PCs up and running over here. So this is PC1, left top corner, and let's do PC2. That is top right corner. So let's do that right over here. First of all, 2.51, which is this guy over here, and this guy should be able to ping 1.51. PC1, which is this guy, should also be able to ping router 2, which is 2.2. So my whole network right now, up until router 2, is working properly. Now the next thing, the next VLAN is this guy over here. This interface we have taken care of already. This interface actually I've taken care of. I'll just show it to you. The only thing that I need to do for VLAN 30 is this SVI. The SVI for VLAN 30 with an IP address. I'm going to assign an IP address of .11. All right, so 3.11 is my SVI on switch 2, and that's what I'm going to use as my default gateway. I'm going to use him as the default gateway over here. Let's take a look at it, how to do it. As I said, the PC is done. I'll just show it to you. So PC over here is 3.51 with the default gateway of 3.11, which is going to be the SVI on switch 2. So how do I do that on switch 2? How do I make it into a layer 3 switch? IP routing. I think I had done that already, but doesn't harm doing it again. And then my SVI 30 for VLAN 30. Again, take a look at your topology. SVI 30 over here. Okay, and then I will assign it an IP address we agreed upon, 3.11, because that is being used by the PC as the default gateway. No shut. So this VLAN 30 interface, which was down now, should come up. And if I do show IP interface brief, I should see the VLAN interface over here up. VLAN 40 I haven't configured yet, but 3 is up. Now I should be able to ping 3.51, and 3.2 should also be pingable because 3.2 is also on this network. I don't have routing right now, so I won't be able to go beyond that. I will do that in the next step. But before that, what is the other interface that I have over here? The other SVI that I have is 192.168.4.11. Again, 3.11 and 4.11. The SVI towards VLAN 40. Let's do that also over here. VLAN 40 IP address 192.168.4.11. Bring it up. My two interfaces now, the two layer 3 interfaces should be up. There you go. Let's run routing. Router EIGRP 100, just like you run on a router. My network is 192.168.3.0. Enable that and the 4.0. As you guys can see, my neighbor just came up with 3.2, which is router 2. And if I take a look at my routing table now, just like on a router, I see 1, 2. So which basically completes my topology at this point, not only for here, because I'm running routing. My PC4 was already configured. It was already pointing to this guy. I've configured the two interfaces on here and ran routing. So now I should be able to hit PC1 to PC4 over here. So that would complete my physical topology and my logical topology. And I'm basically able to go from one end to the other end once I actually ping it. So let's do that. Let's go and do all the pings now to verify my topology. So I'm on 1. So 1 should be able to ping 2.51, which is PC2. Should be able to ping 3.51 and 4.51. All pingable. This is PC2. This guy should be able to ping 1.51. I'm 2 myself, so I'll ping 3.51, 4.51. Okay, let's go to 3 now. Should be able to ping 1. Now 1.1, 1.51. That's PC1. 2.51. I'm 3. I'm not going to ping myself. 4.51, which is PC4. And this PC, which is on the edge, should be able to ping 1.51. From one edge to the other, 2.51. And 3.51. So I have mapped over this physical topology to my logical topology. I've configured a routing protocol over here, and I've allowed all the PCs to talk to each other via these routers. Not only did I show you how to do a physical to logical, I also showed you the 3 different ways of doing inter-VLAN routing. In terms of importance, I would rank this right at the top of importance in terms of you guys understanding how to do this. If you haven't, go through the video again, take a look at each step, practice it over and over again until you feel comfortable with it. Hope you guys enjoyed it. Thanks for watching. See you guys in the next video.